In this problem, we're asked to find the critical values and the maxes and mins on this closed interval. So how do we do this? How does this look? Well, first of all, we want to find the derivative. F dash of x, or f prime of x, is multiply and subtract, multiply and subtract. So I'm using the power rule. Notice what is in parentheses essentially is x, and so the derivative of x is 1. So if I use the chain rule here, I'd just be multiplying by 1. So what do we do to find critical values? We just found the derivative, set that equal to 0. Now, what I want to use is the zero product property. The zero product property says if a times b equals 0, then we can conclude that this factor a must be 0, or this factor b must be 0, or both. Notice I'm using that word factor. When I say factor, I mean something times something. If they equal 0, we can be detectives and say, well, one of them or both of them must have been 0 to give us a product of 0. So I try to factor out what's common to both. 12x squared is common, and I'm left with x minus 1 equals 0. Now let's see, did I get it right? 12x squared times x is in fact 12x cubed, and 12x squared times negative 1 is in fact negative 12x squared. Now that I've got this times that equals 0 by the zero product property, and this only works when our right side of the equation is 0. We don't have a 1 product property or a negative 1 product property or 5 product property. It's got to be 0 over here. I can conclude that 12x squared must be 0, or x minus 1 must be 0, or both. Divide both sides by 12, I get x squared equals 0. Take the square root, and I get x is equal to 0. Add 1 to both sides, and I get x equals 1. So here are my critical values. Now, what I'm going to do is I'm going to find the function value at 1. And when I plug that in, if I go 3 times 1 to the 4th minus 4 times 1 to the 3rd, the function value at 1, I'm going back to my original equation, is negative 1. And when I find my function value, I'm going back to the original equation. If you want the y, go to the y equation. F of 0, I'm going to put in a 0 for my x, is 3 times 0 to the 4th minus 4 times 0 to the 3rd gives us 0. So I get this point 0, 0. So I like to make a little chart. I'll say left endpoint, critical value, right endpoint. And if I make this little chart, I can easily compare. Now, I've already got my critical values where my derivative is equal to 0. That was at 0, 0, and 1, negative 1. The critical values are the x value. The function value is the y value. The left endpoint, well, I started at negative 1. So if I find f of negative 1, now I'm going here. So that's going to be 3 times negative 1 to the 4th minus 4 times negative 1 cubed. I have to follow PEMDAS, parentheses, exponents, multiplication, division, left to right, addition, subtraction, left to right. I'm going to get 7 here. So I have negative 1, 7. And when I do my function value at 2, if I find f of 2, I get 16. I didn't show that, but what am I doing? I'm doing 2 to the 4th times 3 minus 2 to the 3rd times 4, and that's going to give me 16. And now, once I've got this scoreboard set up, I can easily see that my highest y value is at the endpoint. So here's my absolute max, and my lowest y value is at this second critical value. So here is my min. That's all I have to do. I had to find my critical values. Here they are, where my derivative was 0, using that 0 product property. And then I just had to investigate the left endpoint and the right endpoint. The tallest or the biggest y value is the max. The lowest y value is the min. Looking again at this problem, could we sketch it? Sure we could. Negative 1, 7. I'm going to put my point there. There's my left end point. It goes through 0, 0, and then 1, negative 1, and then finally 2, 16. So my graph is going to look something like this. Ooh. Now, it doesn't turn around because then we'd have another turnaround. So it must sort of look like a slide and then come up. And so here's our point, 2, 16. And this is negative 1, 7. And here we have 1, negative 1. And this point here, 0, 0. Notice 0, 0 is kind of like a way station. It wasn't a relative min because if it were a relative min, I would have had to turn around again, and there's no maximum value here. So I know this is a reasonable sketch for my graph. And if you do this on a graphing calculator, you'll see that I have a very reasonable sketch here. Now also look here. Our absolute min has a y prime of 0. And where our graph has this sort of way station point here, our derivative is also 0. That's how we were getting these critical values. Notice here, although the derivative is 0, it didn't give us an absolute max or an absolute min, or even a relative max or relative min. So sometimes that can happen.